The next step in AI isn't just building smarter assistants or more powerful models, but extending autonomy to something deeper, self-improvement. At first, the idea of self-evolving AI agents might sound futuristic, but in reality, a lot of the necessary building blocks already exist today. Let's break it down. One key element is the agentic workflow, the planning an agent does before taking action. OpenAI demonstrated this by training an AI agent on call center data. Once human agents adapted their way of working to follow the AI-created workflows, productivity and efficiency improved significantly. This shows how workflow design alone can evolve how we work. Now, let's turn to another crucial development, NVIDIA's data flywheel principle. NVIDIA introduced a framework where agents continuously learn from feedback. Imagine an AI system fine-tuned on how tools are called over time. It becomes progressively better at choosing the right tool for the right situation. This creates a powerful, self-improving feedback loop. Similarly, in tool calling optimization experiments, smaller models were fine-tuned to be highly effective in tool use. The results point toward agents that aren't static, but evolve dynamically as they operate. Now, add another breakthrough into the mix, the Freeform function calling features of GPT-5. Unlike static function calls, Freeform functions let an AI agent dynamically decide what code to generate and execute in order to fulfill a user's request. This brings us much closer to autonomous agents that can write their own code to solve problems on the fly. To illustrate, imagine giving an agent a complex request. Instead of selecting from predefined functions, it writes the exact Python code necessary, executes it, and adapts based on the outcome. That's a major leap forward because it moves agents away from dependence on fixed tools toward true adaptability. But tools and workflows are only one side of the story. For self-evolving AI, memory plays a central role. Context refers to the working set of information at a given moment, while memory is the accumulated history that informs context. The ability to continuously draw from and refine memory structures is essential if agents are to learn and evolve over time. We also need to consider the domain of these agents. Broad solutions like those from Anthropic, OpenAI, or xAI aim at general-purpose autonomy. But for enterprises, specialists, and SMEs, what's needed are domain-specific agents, built with SDKs and customizable frameworks. This adds another layer to the evolution puzzle. Agents must adapt within a domain to truly improve the workflows of their users. So the big questions become, what should evolve? When does adaptation occur? And how do we measure success? Evaluation goals range from adaptability and retention to efficiency, with both short-horizon and long-horizon assessments. Pulling all of this together, we see the path of evolution, from large language models to agentic solutions with tool execution to the next generation, self-evolving agents. Today, we are in the execution via tools and planning phase. But experiments from NVIDIA and capabilities like GPT-5's Freeform functions hint that the next leap, agents that learn continuously from feedback and experience, is already underway. So while the phrase self-evolving AI agents might sound like the distant future, the truth is the seeds are being planted right now. And the companies making progress here are not just building better models, they're moving us closer to a world where AI agents can improve themselves just like we do.